Now that you're familiar with the different methods for solving systems of linear equations, we're next going to consider some applications that use those kinds of systems. And the first example we're going to look at is the following. We're told that all 100 seats in a movie theater are sold out for a showing. Adult tickets cost $5 each and children's tickets cost $3 each. If the total revenue from the showing was $430, the question we're asked then is how many of each kind of ticket was sold. Now you recall that the best first step in solving any application problem is to organize the information in the problem into what's known and what's unknown. So let's do that next. So in the known column you can see we have these items listed, that there were 100 seats total in the theater, that each adult ticket cost $5, each children's ticket cost $3, and the total revenue taken in from the sale of all the tickets was $430. And what we don't know would be the number of adult tickets sold and the number of children's tickets sold. So what we need to do next is to represent each of the unknown items in terms of a variable, and then write a system of equations that ties the known and the unknown information together. Now, since there were two things listed under the unknown column, we're going to represent each of those using a different variable. And in any application, you want to be very detailed and specific when you define the variables that you use in the problem. So we're going to let X be the number of adult tickets sold and Y the number of children's tickets sold. And because we've introduced two variables in the problem, we need to write two equations using those two variables. Now the first, I think, hopefully will be fairly obvious. We're told that there were 100 seats total in the theater. So we then can write that X plus Y is equal to 100. Now the next equation will be related to the revenue. Now I hope it seems reasonable that if we have sold X number of adult tickets and each ticket costs $5, that the revenue taken in through the sale of the adult tickets will be 5 times X. And in a similar way, if we've sold Y children's tickets and each cost $3, that the revenue taken in from the sale of the children's tickets will be 3Y. Then adding those two together then will give us the total revenue, which we're told in the problem is $430. So that now is our system of equations. Now, to solve this, we could either use elimination or substitution. And I think I'm going to lean towards substitution here. What I'm going to do is take and solve the first equation here for Y, and write Y is equal to 100 then minus X. So let's substitute that expression for Y in the second equation. So we then have 5X plus 3 times the quantity 100 minus X is equal to 430, and then 5X plus 300 distributing here minus 3X is equal to 430. And combining terms, we can see that we'll have then 2X plus 300 is equal to 430. And if we subtract 300 from each side, then we'll have 2X is equal to 130. And dividing each side by 2, we can see that X will be equal to 65. And then to find Y, we can go back to the equation up here. So Y then will be equal to 100 minus 65, or Y then will be equal to 35. And so what we'd like to do then is to end up with a sentence answering the question posed. So we can end up by saying then that there were 65 adult tickets sold, and 35 children's tickets sold. Now it's pretty clear that the 65 plus 35 equals 100, which means it satisfies the first equation. So let's next check those values in the second equation. Now let's next check the values we found for x and y in the second equation of our system, which involved the revenue. And so as you can see, I've substituted the 65 for the x and 35 for y. And if we multiply 5 times 65, that will produce 325, and 3 times 35 will be 105. And adding those two together, we get 430. So we can see that our values for x and y do indeed check in the second equation.